progressive wave, for generation of progressive wave, first of all a source is required. Okay, a source is required. What is a source? A source is a vibrating body. Okay, so this is the source. This is a vibrating body. Surrounding the source, there are particles of medium. Okay, so these are all particles of medium, invisible particles. These are the particles of the medium. The source vibrates, and the vibration of the source spreads through the medium. Okay, or vibrational energy of the source, vibrational energy, the source is vibrating, so it is having some energy. That energy transmits through the medium. Okay, how is it transmitted? By way of periodic vibration of the particles of the medium. Okay, so what is transmitted from source or away from source? Energy of vibration of the source is transmitted through the medium. How is it transmitted? By way of periodic vibrations of the particles of the medium. Each particle executes SHM. Each particle executes SHM about its mean position. So the energy of the source will fall on this particle. This particle will start vibrating. Then the next one will start vibrating. Then the next one will start vibrating. By the time this particle has started vibrating, the first particle may stop. That means the energy of vibration has been transferred from the first particle to this particle. Okay, when this particle starts vibrating, then this particle starts vibrating. By the time it starts vibrating, this particle may stop. That means energy of vibration has gone from this particle to this particle. In this way, energy is transferred from the source to destination. Okay, and how is it transmitted? It is transmitted by way of periodic vibrations of the particles of the medium. Okay, we assume each particle to vibrate with same amplitude and time period. But actually the amplitude of vibration reduces as one goes away from the source. This particle vibrates with maximum amplitude, then the next particle, the amplitude of vibration is slightly reduced, then the amplitude of vibration of this particle is little reduced. That is what is known as damping. That means there is friction. There is friction between particles of medium. Because of that, energy is lost. Energy is lost. So the particle which is closest to the source, it vibrates with maximum amplitude. Then next particle will actually vibrate with slightly reduced amplitude. Okay, so that's why when I talk or when you talk, sound is heard only within certain distance. Beyond that, sound will not be heard. Because if the distance is large, the amplitude will gradually reduce to zero, and once the amplitude of vibration becomes zero, sound will not be heard. Okay, so have you got this point? But here we are assuming an idealistic situation, an ideal situation in which we are assuming that all the particles vibrate with same amplitude and time period. We are assuming, but actually the amplitude of vibration gradually reduces away from the source. Is this point clear? So what is transmitted from source? Energy. How is it transmitted? By way of periodic vibrations of the particles. Okay, and what is the characteristic of periodic vibration? Each particle executes SHM with same amplitude and time period. Ideal situation. Okay, then another important thing, particles are not swept in the direction of the wave. Okay, this is a particle of the medium. I am talking. Okay, the source is my vocal cord. The vocal cord starts vibrating. That is the source. then the vibration is induced in this, it starts vibrating, then the next particle starts vibrating, so both continue, okay, and then this stops, but this goes on vibrating. That means energy goes from this particle to this particle, okay. And once the disturbance is passed, this particle will come back to its mean position. Okay, so there is this particle receives disturbance, starts vibrating, disturbance passes to the next particle, this particle will stop at its mean position. It will wait for another disturbance. Again another disturbance falls on this, it will start vibrating. So do not assume that the particles are driven in the direction of propagation of wave. So this is another important characteristic, that particles are not swept in the direction of propagation of wave. Okay, and another important characteristic, most important characteristic is, between the vibrations of two particles there is a phase difference. What is the basic meaning of phase difference? There is a time lag between the start of vibrations of two particles. There is a time lag. There is a time lag. Means one particle starts its vibration earlier than the other particle. In that case, there is a phase difference. But if both the particles start vibrating at the same instant like this, the phase difference is zero. This starts earlier, next particle is pulled, so and this type of motion follows. Okay, you may assume that these two particles are connected by a rubber membrane, elastic membrane. So as this goes, the membrane gets stretched and this one is pulled. And as it starts coming down, again the membrane gets stretched and this also starts coming down. Okay. So this is actually transverse wave, you know, this is transverse wave, and for generation of transverse wave, media must have sufficient elasticity. Okay, so now write important characteristics. This will be very important, may come in your exam. Under this question is, write the characteristics of progressive wave. Write the characteristics of progressive wave. First point, for generation of progressive wave, a source is required. For generation of progressive wave, a source is required. The source is essentially a vibrating body. For generation of progressive wave, a source is required. The source is essentially a vibrating body. Second point, energy of vibration of the source, transmits through the medium, by way of periodic vibrations, of the particles of the medium. Third point, each particle of the medium taking part in the propagation, of wave, vibrates with same amplitude and time period. Vibrates with same amplitude and time period. Next point, the particles of the medium taking part in the propagation of wave, particles of the medium taking part in the propagation of wave are not swept in the direction of propagation. The particles of the medium taking part in the propagation are not swept in the direction of propagation of wave. After the disturbance, same point, after the disturbance passes away, particles come back to their mean positions. Next point. There exists a definite phase difference. Between the vibrations of neighboring particles. There exists a definite phase difference between the vibrations of neighboring particles. It is because of this phase difference, energy transmits from one particle to the next. It is because of this phase difference, energy transmits from one particle to the next. I will explain the last point. How is phase difference important for transfer of energy? Consider this example. In army, when some construction work is carried out, suppose a road is to be repaired, for that bricks are required, and this is the brick stack, this is the stack from which bricks are to be collected and taken to the construction site. Army men will form a line. They will stand in row connecting the brick stack and the construction site. Okay. The man closest to the source, closest to the stack, will pick up a brick and he will transfer it to the next man. Then this man will transfer it to the next man. Then this man will transfer it to the next man. And the brick will reach the construction site. Okay. We will study the movement of the hands of two neighboring men. Okay. This man has collected the brick and he is in the process of transferring it to the next man. So he will move his hand towards right with the brick in his hand, he will move his hand towards right, and the next man who has to collect it will move his hand towards right, towards left, and this man will move his hand towards right. Okay, so what is the phase difference? When I am moving my hand towards left, you are moving your hand towards right. So there is a phase difference of pi. 180-degree phase difference. There is a phase difference of pi. And because of this phase difference only, this man can catch or can collect the brick. Okay, so because of this phase difference, brick goes from this man to the next man. Now assume a situation that they are moving their hands. They are moving their hands in such a way that there is no phase difference. There is no phase difference. That means when this man who is holding the brick has moved his hand towards left, at the same instant the next man also has moved his hand towards left. So the brick will fall on the ground. Okay, so what is essential for the transference of the brick? Phase difference. 180-degree phase difference. Without that, this man will not be able to collect the brick. Okay, and no phase difference means moving hands in same direction at the same instant. Where do you find no phase difference? During March past, you have seen absolutely no phase difference. Okay, so phase difference is must for transference of the brick. Phase difference is must for transference of energy. Okay, these people, they do not move in the direction of propagation of the brick. Okay, here also particles do not move in the direction of propagation of wave. Okay, but the energy is transferred from one particle to the next particle. Okay, by way of periodic vibration of each particle. And between two neighboring particles, that phase difference is must. Without that, energy will not be transferred. Okay, so remember, do not forget at all that phase difference is the most important characteristic of progressive wave. How is a progressive wave recognized? How is a progressive wave identified? By seeing the phase difference. Okay, I will now derive the equation. There the phase difference term will appear, and this phase difference term is the characteristic feature. If you do not find that term, that means it is not a phase, it is not a progressive wave. If you find that term, then this is definitely a progressive wave. Okay, so write the next equation and next question. Find the equation of progressive wave. This is the case 1. We will discuss two different cases. In one case, the wave will travel from left to right. In another case, the wave will travel from right to left. Okay. So in one case, I am talking. So progressive wave is generated and it is traveling in your direction. That is one case. Then you are asking me a question. Wave is traveling in opposite direction. Both the cases will be discussed separately. Okay. So case 1. This is the source. We will consider two particles. One is particle A and the other one is particle B. These are two particles of the medium. The distance between these two particles is x. Okay? And are oscillating, both are executing SHF. Y is the, this is the mean position, we are measuring displacement from mean position. Y is the displacement of particle B. At what time? Y is the displacement of particle B t second after A has started its oscillation. So when you derive the equation of a progressive wave, a reference particle is must. In this case, A is the reference particle. Why is reference particle must? Because the most important characteristic feature of progressive wave is phase difference. So when it is difference, when you are talking about difference, then another particle has to be considered. So that's why a reference particle is must. A is the reference particle and we are studying the displacement of B. So Y equal to displacement of B t second after A has started its vibration. So what do you understand by equation of wave? What is the meaning of equation? That is what you are going to find out. By equation we understand displacement as a function of time. Displacement as a function of time, that expression is called equation. Okay, that means we find Y as a function of t. Okay, amplitude of vibration is A. Amplitude of vibration is A. Means maximum displacement is A. Okay, we have written this part. Consider circular model. Consider circular model. All of you remember circular model? A particle will rotate with uniform speed. Its foot of projection means a perpendicular drawn from the particle on any diameter executes SHF. In this, which particle is leading in phase? A. So A will be placed ahead of B. This is A or A dash, and this is A. In this direction it is rotating. The foot of projection is going in this direction. And compared to A, B is lagging in phase. So that's why B will be placed here. B dash, its foot of projection, this is B. This is B. Okay, B dash is going in this direction. Its foot of projection B is going in this direction. A is leading in phase, B is lagging in phase. Okay. Which angle is omega into t? Is the angle made by B dash with the center omega into t, or angle made by A dash with the center is omega into t? Which angle is omega into t? See, you are measuring time. You are measuring time from the start of vibration of A. That means angle made by A is omega t. This is omega t. You are measuring time from the start of vibration of A. That means angle made by A. This is omega into t. And what is the angle between A dash and B dash? that angle is called the phase difference between these two particles. Okay, so I have marked that angle as phi. So what is phi? Phi is the phase difference between the two particles. Okay, and what is y? Displacement of A or displacement of B? Displacement of B. That means this is y. This is y. देखो ठीक है कि नहीं? Is it okay? First, A is leading in phase. So A has been placed ahead of B. B is lagging in phase. The phase difference between the two is phi. Time is measured from the start of vibration of A. So that's why this angle made by A dash with the center. Okay, angle made by the line connecting A dash and center is omega t. And there is a phase difference of phi between A and B. And y is the displacement of B. So now, y equal to, amplitude is A cos, y equal to A cos omega t minus phi. This is the equation of progressive wave. Okay, when the wave travels from left to right. Okay, have all of you understood this part? Now I will consider case 2 in which the wave will travel from right to left. Have you drawn this? Drawn? Wave travels from right to left. Wave travels from right to left. So what will be the change in drawing? Only the source will shift. Source will shift from left to right. Okay? There will not be change. Will you change the two particles? Will you also change? Will you write this as A, this B? No. That will not do. Because the difference is only in the position of the source. These are the particles of the medium. Okay. Previously I was talking and the wave was traveling in your direction. Now this is particle A, this is particle B. Now you have started talking and wave has started coming in my direction. But see, there is no change in the two particles. So this particle remains A, this particle remains B. There is no change in the particles. Only the source has changed its position. Okay. So that's why there is no change in the particles and there is no change in the statement also. Y equal to displacement of B t second after the start of vibration of it. No change. The only change is the source has gone to the other side. There is absolutely no change. A and B remain unchanged. The statement also is unchanged. Okay? But this diagram, circular model will change. Who is leading in phase now? B is leading in phase. So B will be placed. I will place B here ahead of it. Reason is B is now leading and A is lagging because B has started its vibration earlier than A. That means B is leading in phase. Which angle is omega t? We are still measuring time from the start of vibration of A. So angle made by the line connecting A dash with the center is omega t. This angle, omega t. And the phase difference between these two particles is phi. And y is the displacement of B. This is B, this is A. This is Y. Now write Y from the drawing. Amplitude is A. A cos
omega t plus
A cos okay. So when is this sign plus? Wave travels from right to left. So along negative x-axis plus, along positive x-axis minus, opposite. Okay? Hence, the equation is equation of progressive wave. Y equal to equation of progressive wave A cos omega t plus minus phi, or this may also be sin omega t plus minus phi, then plus when or plus for right to left, right to left travel, minus for left to right travel. So what is visible in the equation? Phase difference, you can see this phi. It is the essential characteristic, most important characteristic of rotation. With phase difference between the vibrations of these two particles is pi. Again, what is the phase difference between the vibrations of these two particles? It is pi. So what is the phase difference between these two particles? Phase difference between these two particles is 2 pi. So phase difference between these two particles is 2 pi, and what is their path difference? Lambda. Lambda. Path difference is lambda. So this gives us a relation between path difference and phase difference. Lambda path difference is equal to 2 pi phase difference. So we'll use this fact. Lambda path difference equal to 2 pi lambda path difference equal to 2 pi phase difference. One path difference equal to 2 pi by lambda phase difference. And what is the path difference in between A and B? X. X path difference equal to 2 pi x by lambda phase difference. Okay. So what is the x path difference is equal to 2 pi x by lambda phase difference. But we have assumed this phase difference to be phi. Hence, x path difference equal to 2 pi x by lambda phase difference. That means if two particles are at separation x, if two particles are at separation x, then their phase difference is 2 pi x by lambda. So these two particles are at separation x. So their phase difference is 2 pi x by lambda. So in place of phi we can put 2 pi x by lambda. Have you understood this? This is very important. And not only in class 11, again in class 12 you have wave optics. In wave optics all these things will be required. Okay. So I will now write another form, y equal to a cos omega equal to 2 pi by t, all of you know. Phi equal to box this also. Equation of progressive. Find a relation between the speed of the wave and speed of a particle of the medium, that has taken part in the propagation of wave. So how will you relate these two? Velocity of wave and velocity of particle. How will you relate? What is same? What is same in both?
Omega.
No, amplitude is no. In the speed of wave there is no amplitude. What is common?
N equals to 1 by t or omega equals 2 pi by t.
That is correct. N and omega. N equal to 1 by t and t equal to 2 pi by omega. So omega is same for both particle speed and wave speed. Omega is same. Other things are all different. So if you are to find a relation between the two, then express it. N equal to, I will write N equal to 1 by t into lambda. Then t equal to, I will write 1 by t equal to omega by 2 pi into lambda. Then these two omegas are same. Okay, so you may find omega from this and put here. To get a relation between the two, find omega from this and put. Hence, omega equal to 2 pi speed of wave divided by lambda from 1 and 2. From equations 1 and 2, V particle equal to 2 pi V wave by lambda into root over a square minus y square, or V particle by V wave equal to 2 pi root over a square minus y square by lambda. And you need not remember it as a formula. Only learn the technique that omega is same for both. We will find omega from both and we will equate them. So this is the relation. Stationary wave is also called standing wave. Okay, stationary wave or standing wave. Consider a long rope, okay, or a string, long string. One end of the string, is fixed to the wall. You are holding at the other end. And imparting upward and downward jerks. Okay, so holding one end of the rope, you are just oscillating it like this. So this will generate what? If you go on imparting jerks to this, then this will generate wave in this, and the wave will travel in this direction. Okay, so one after another waves will be generated and they will travel in this direction. Then these waves will be reflected from the wall. Okay, these waves will be reflected from the wall and they will superpose. Means incident wave and reflected wave, they will come together and they will superpose. The result of this superposition is a standing wave or a stationary wave. Here we are assuming one thing. We are assuming this wall to be a perfect or to be an ideal reflector. What is an ideal reflector? Ideal reflector does not absorb any energy, any part of the energy of the incident wave. Okay, but a real reflector always absorbs a part of the energy of the incident wave. You may consider a simple mirror. Let sunlight fall on the mirror. Okay, so we are amazed. So sunlight is falling on this, and then if you rotate, if you vibrate, or if you just change the angle, then reflected sunlight will fall on the ceiling, and we are fascinated in seeing that it is moving. Now consider the brightness of the sun and the brightness of the bright spot, which is or illuminated spot that has formed on the ceiling. Okay, the brightness of the illuminated spot which is moving on the ceiling is much less compared to the brightness of the sun. Compared to the brightness of the sunlight, the brightness of the illuminated spot which is moving on the ceiling is much less. Why is it less? Because the mirror has absorbed lot of energy of the incident sunlight. Okay, so mirror is not an ideal reflector. If you assume this to be an ideal reflector, then only the reflected wave, it will be identical to the incident wave. Identical. And when such identical waves superpose, the result is stationary wave. Okay, so write this. When two identical waves traveling through same medium in opposite directions, are superposed, the result is a stationary wave. The result is a stationary wave. Okay. Now write the next question. Next question. Find an equation of stationary wave. Find an equation of stationary wave. So consider this wave. This is the incident wave. Y1 equal to, suppose it is a sine 2 pi t by t. It is traveling from left to right. That means minus 2 pi x by lambda. This is the reflected wave. Y2 equal to a sine going from right to left, means this will be plus 2 pi t by t plus 2 pi x by lambda. By principle of superposition, for the resulting wave, y equal to y1 plus y2. This is called superposition, principle of superposition. Okay, so what is principle? If this question comes, I have not discussed it separately. What will you write? If the question comes, what is principle of superposition? This is a particle of the medium. This is a particle of the medium. Okay, several persons are talking. I am talking, you are also talking at the same time. So due to my speech, a wave is falling on this. Due to his speech, another wave is falling on this. Due to your speech, it is another wave is falling on this. So how will the particle vibrate? Okay, will it vibrate to the tune of my speech or will it vibrate to the tune of your speech? Answer is principle of superposition. Due to my speech, if it is y1, due to his speech, if it is y2, due to your speech, if it is y3, suppose all the three things are in different directions, then you will have to apply the vector form. What is vector form? Simple. Y vector equal to y1 vector plus y2 vector plus y3 vector. Now in this we are not considering vector form because all are along same line. Okay, but these vibrations are also along same, parallel to each other. So that's why y equal to y1 plus y2. So you will write, do not leave that question. Principle of superposition, simple. This equation has two parts. Every equation has two parts. One is the amplitude part and the remaining is the phase part. One is the amplitude part, the remaining is the phase part. If you consider this progressive wave, this is a progressive wave. This is the amplitude part. This is the amplitude part. And this is this sine 2 pi t by t minus 2 pi x by lambda. This is the phase part. So phase part has omega t in it. Phase part has 2 pi t by t in it. Okay. So in this, can you see that this is the phase part? Sine 2 pi t by t. This is the phase part. And the rest is the amplitude part. So that's why I'll write it in this form: 2a cos 2 pi x by lambda sin 2 pi t by t. 2a cos 2 pi x by lambda sin 2 pi t by t. This is the amplitude part, and this is the phase part. With this, compare the equation of a progressive wave. Compare. This is the equation of a progressive wave. Compare. What do you find in the phase part? What is the difference in the phase part?
That is 0 হবে, plus 0
Plus 0. That means there is a very striking difference. Striking difference is, here you have omega t plus minus phi, but here you have only omega t. That means you have 0 here. You have 0 here. So what do you conclude? Oishani, what do you conclude? Between two particles of the medium, there is no phase difference if it is a stationary wave. So remember, there are two important points. This is one of those 2 points, that between two neighboring particles, the phase difference is 0. And now study the amplitude part. Herein, what difference do you find? This is the amplitude part. This is the amplitude part in progressive wave. This is the amplitude part in stationary wave. What difference do you find? Here it is A. A means A. It does not depend on position of the particle. It is A. Means for all particles, amplitude is A. For all particles vibrate with same amplitude. There is phase difference. You may find one particle at the peak while this is here. But amplitude of this particle is A, amplitude of this particle is also A. It is only a matter of time that this particle will reach the peak. Okay? This will come down, this will reach the peak. Means each particle has amplitude A. Okay? And what do you find here? Amplitude of oscillation of a particle depends on X. What is X? In waves, what is X? Position. Okay? So, amplitude of oscillation of a particle depends on its position. Depends on its position. So, a position is such that this particle, that for this particle, X, value of X is such that cos theta is 0. So, this particle will not vibrate. Value of X is such that cos theta equal to 1. Cos theta equal to 1. So this particle will vibrate with large amplitude. Okay. So it depends on position. Okay. Amplitude of vibration depends on position. The position value of X is such that cos theta is 0 and this particle may not vibrate at all. If cos theta is 0, amplitude of vibration will be 0. While X, value of X is such that it vibrates, here cos theta is 1 and it vibrates with maximum amplitude. So it depends on the position. Not all the particles have same amplitude. Okay. So I will now show this. Now we will discuss the characteristics, right? But before writing the characteristic, I should write the equation of stationary wave. Equation of stationary wave. Y equal to first I am writing this cos 2 pi x by lambda sin 2 pi t by t 2a sin 2 pi x by lambda cos 2 pi t by t 2a sin 2 pi x by lambda sin 2 pi t by t 2a cos 2 pi x by lambda cos 2 pi t by t, all are possible, huh? Cos, sin, cos, sin, cos, all are possible. Depending on type of reflection, I will illustrate how all are possible. Depending on type of reflection, all are possible. Okay, so all the equations are possible depending on type of reflection. Okay, so I have stated type of reflection. I will discuss different types of reflection and how different equations are obtained. Okay, but before that, I will discuss the characteristics of stationary wave. Right? Question. Write the characteristics of a stationary wave. We are considering a stressed wave. In this stressed wave, you have produced vibration. That means you have plugged the string at some point. A wave has been generated. That wave has traveled along the length of the wave, and it has been reflected from the wall. Then the incident wave and reflected wave, they have superposed, and as a result, a stationary wave has been produced in the string. Okay, suppose this is the stationary wave that has formed. What does this dotted line mean? The dotted, no, not that. Dotted line indicates the wave after t by 2, half time period. Okay, because after half time period, this will come down, this will go up, and this will come down. Okay. Then, what will be the equation of this? Which one will you select? Cos. Now, we are measuring x in this direction. So at x, this is x equal to 0. At x equal to 0, what is the amplitude? 0. So will you go for cos? Because for cos at x equal to 0, cos 0 is 1. So we will not go for cos. We will go for sin. Either this or this. Okay. First, this part. Amplitude of this particle is this much. Amplitude of this particle is this much. Amplitude of this particle is this much. Amplitude of this particle is 0. So what is the amplitude of this particle? And amplitude of this particle is 0. See, all these particles are going up together. At the same instant they are going up. But one is going up to this position, but another is going up to this position. Okay? Then the particles belonging to the neighboring loop all are going downward at the same time. This particle is going to this position, this particle will go to this position, and this particle will go to this position. Then in this, this goes to this position. Okay, all the three are going up at the same instant. Okay, try to understand the difference. We indicate progressive wave in this way, in similar manner or in similar way. We indicate progressive wave, but there you cannot tell that the amplitude of this particle is this much. But here you are telling that the amplitude of this particle is this much. Okay, why don't you tell that amplitude of this particle is this much in a progressive way? Then what does it show? This graph is almost this is same as this. But you don't tell that amplitude of this particle is this much. Why you don't tell? What do you know? What do you know? That's why you know something, that's why you don't tell. Same means this particle at the given instant, this particle is visible here. But it does not mean that the particle will reach up to that position. It does not mean. This particle is in motion and it is in the process of going to the top. So that means it is only a matter of time that this particle will reach the peak and this particle will come down. So you find a particle here, that does not mean that the amplitude of this particle is this much, because it is in the process of going in this direction, and only after a short while it will reach the peak. That means its amplitude will be, its displacement will be A, and this is coming back to the mean position. Is it clear? So when you draw a progressive wave, then the fact that you know that this particle is moving, and only after a fraction of second this will reach the peak. The waveform will be like this. This will reach the peak and this will come down to this position. This will also come down to this position. So when you find this particle, we just do not conclude that this particle is not vibrating or its amplitude is 0. We cannot conclude that, because this is in motion. It is only a matter of time that this will reach the peak. It is only a matter of time. There is a phase difference. But here it is different. This is a particle will only go up to this position. It is not a matter of time. It will not go to this position. It will only go up to this. Then that means this is oscillating. This particle is oscillating like this, only between these 2 points. While this particle is oscillating with greater amplitude. Okay, it depends on the position. First point, between particles belonging to same loop, between particles belonging to same loop, the phase difference is 0. Between particles belonging to same loop, the phase difference is 0. Between particles, same point. Between particles belonging to neighboring loops, the phase difference is pi. And between particles belonging to alternate loops, the phase difference is 2 pi. Between particles belonging to alternate loops, the phase difference is 2 pi. Now follow the drawing. Between this particle, when this particle is going up, this particle is coming down, so the phase difference is pi. And again, this particle is going up, this is going up, so phase difference is 2 pi. So this is one point. Next point. The amplitude of oscillation of a particle is given by 2a sin 2 pi x by lambda or 2a cos 2 pi x by lambda. Hence amplitude of oscillation of a particle depends on its position x. Depending on the position, amplitude is 0 or 2a or between 0 and 2a. Depending on position, the amplitude is 0 or 2a or between 0 and 2a. Next point. The particles and not the particles. You write the positions where the particles vibrate with maximum amplitude 2a. The positions where the particles vibrate with maximum amplitude 2a are called antinodes. And the positions where the particles vibrate or positions where the particles vibrate with the positions where the particles do not vibrate. The positions where the particles do not vibrate are called nodes. Are called nodes. Okay? So now I indicate nodes in this. This particle is not vibrating. This is node. This is also node. This particle is vibrating with maximum amplitude. Antinode. This particle is vibrating with maximum amplitude. Antinode. So antinode, node, node, antinode. This is another antinode. Okay. This particle is vibrating with maximum amplitude. Antinode is not vibrating. Node. Again, this is antinode. Node. This is antinode. About fundamental overtones and harmonics. Fundamental overtones and harmonics. A body that can vibrate, produces different frequencies depending on different modes of vibration. Okay, a body, for example, this body, for different modes of vibration. I am holding the body. If you pluck it here, or if you pluck it here, or if you pluck it here, depending on different modes of vibration, this body can produce different frequencies. Okay, for example, a body can produce all these frequencies: 10 Hz, 15 Hz, 20 Hz, 25 Hz, and 30 Hz. So a body can produce all these frequencies. The minimum frequency that the body can produce is called fundamental. So this is fundamental. This is fundamental. Minimum frequency that the body can produce is called fundamental. All the others, all the frequencies greater than fundamental are called overtones. So these are overtones. Now you have to name overtone. How do you name overtone? You have to arrange the overtones in ascending order. I have arranged all the overtone frequencies in ascending order. You can see 15, 20, 25, 30 in ascending order. So in that ascending order, the overtone that appears first, that comes in the first place, is the first overtone. The overtone that comes in the second place is the second overtone. This comes at the third place, third overtone. Okay? So this is first overtone. First overtone. This is the second overtone. Overtone. This is the third overtone, like that. Okay? And the harmonics. What are the harmonics? The frequencies which are integral multiple of fundamental. The frequencies that are integral multiple of fundamental are called harmonics. Integral multiple of fundamental. The fundamental is 10. So 10 into 1 is a harmonic. 10 into 2 is a harmonic. 10 into 3 is a harmonic. So that means this 20, this is a harmonic. 30 is also a harmonic. And 10 itself is a harmonic. Okay. So this is harmonic. Harmonics. Okay. So now write the minimum. Now first you write a body produces different frequencies. A body produces different frequencies depending on different modes of vibration. A body produces different frequencies depending on different modes of vibration. Depending on different modes of vibration. The minimum frequency at which the body can vibrate, the minimum frequency at which the body can vibrate is called fundamental. Minimum frequency at which a body can vibrate is called fundamental. All the frequencies greater than fundamental, all the frequencies greater than fundamental are called overtones. Are called overtones. An overtone is named. According to its position. An overtone is named according to its position in the ascending order. According to its position in the ascending order of overtone frequencies. In the ascending order of overtone frequencies. In the ascending order of overtone frequencies. Hence, the frequency next higher than fundamental. Hence, the frequency next higher than fundamental is the first overtone. Hence, the frequency next higher than fundamental is the first overtone. The frequencies which are integral multiple of fundamental, the frequencies which are integral multiple of fundamental are called harmonics. A harmonic is named according to the multiplying integer. A harmonic is named according to the multiplying integer. Hence, the fundamental itself is the first harmonic. Hence, the fundamental itself is the first harmonic. Okay? You understood harmonic and overtones? All these are overtones. But this is not a harmonic. 10 into 1, this is fundamental itself is harmonic. Then 10 into 2, this is the second harmonic. This is the third harmonic. Okay? Transverse stationary wave produced in transverse stationary wave listen better. A transverse stationary wave produced in stress string. Transverse stationary wave produced in stress string. Question. Find the frequency of vibration. Find the frequency of vibration of a stressed wire. Find the frequency of vibration of a stressed wire for different modes of vibration. For different modes of vibration. This is a straight string. You will plug the string at some point. A wave will be generated, a progressive wave will be generated, transverse progressive wave, because particles of the string, they will vibrate perpendicular to the direction of propagation. So a transverse progressive wave will be generated in the string that will travel in both directions. They will be reflected, then the incident wave and reflected wave will superpose to produce stationary wave in the string. Okay, for different modes of vibration, we'll get different types of stationary wave. If you plug at the midpoint, then you will get this type of stationary wave. If you plug at this point and this point, and if you touch the midpoint with something, touch the midpoint of the string with something, you may touch the midpoint with the tip of the pen, that is, that point will not be able to vibrate, then you will get this type of progressive wave. If you, for another mode of vibration, you may get this type of progressive wave. In all the three cases that I have shown, the length of the string is L. Here also it is L. Leave some space for naming. After discussion I will name each mode of vibration. Frequency of vibration for this mode is N naught. How will you get N naught? V by lambda. N equal to V by lambda. How much is lambda for this vibration? Consider the drawing. I am drawing a complete wavelength. I have drawn a complete wavelength. So from this point to this point it is lambda, and you have only half of the wavelength present between these two walls. That means